Hi, this is Mike Zellers, and I'd like to spend a little bit of time talking about the difference between data and information and talk a little bit about why relational databases are preferred to other ways of storing data that have happened in the past. First of all, in general conversation, when people use the term data and information, they use them synonymously. However, in the world of information technology, those two words mean something slightly different. Data is a piece, one raw fact. A piece of data is a raw fact about something. Information is when you take those raw facts and combine them and organize them in such a way that it becomes meaningful. The word I like is actionable. In other words, someone can take a look at that data, combined with other pieces of data, and actually come to some conclusions and make some decisions. Let me give you an example. Let's say a sales rep sold $50,000 worth of merchandise in a given month. That's a piece of data. That one raw fact by itself doesn't really tell us anything meaningful. We don't know, did the sales rep have a good month or a bad month? It depends. All right? If we were the sales manager, how would we know whether a sales rep that sold $50,000 had a good month or a bad month? Well, we would look at other pieces of data and organize them all together. We might look, for example, to see what the quota for the sales rep was for that month. Maybe the sales rep was expected to sell $100,000 worth of merchandise, in which case he didn't have a very good month. Maybe, on the other hand, the sales rep was only expected to sell $30,000 worth of merchandise, and therefore the sales rep had a very good month. Additionally, we might look at things such as what other sales reps sold for the same period of time. We might look to see what that sales rep sold in previous months. We might look to see what the sales rep sold in that particular month of the previous year. All these things, when you put them all together, then we would have something that was actually meaningful and something that we could come to some conclusions about and make some decisions. Relational databases really allow us to do that much better than other methods of storing data. In the past, instead of relational databases, file processing was used. Now, what do we mean when we talk about a file? We talk about pretty much a little self-contained entity that stores data. And it stores data about one particular aspect of the business. It was very difficult when things were stored that way to share data and to bring data together. I'm not saying it was impossible, but it was difficult. All right? Because you might have, for example, an employee file that contains all the information about employees. You might then have, as a separate file, a sales file that keeps track of all the sales that the organization has. All right? And I'm not saying it was impossible to tie those two things together, but it would be difficult to. All right? Programmers would have to write special routines to bring the data from one to another together, and so on and so forth. The other problem that you run into is the problem of redundancy. Because if you have these little self-contained files, oftentimes what happens is data was duplicated between those files. So, for example, you might have a sales rep's name in the employee file, along with his phone number and so on and so forth. You may have the same information duplicated in the sales file as each salesman made their sales for the given period of time. What's the problem with redundant data? Well, if it changes, then it's difficult to update. Because let's say a sales rep changed or moved and had a new phone number. Well, you'd have to update it in several different places. If you have to update it in several different places, there's always a chance that you're going to do it incorrectly. All right, and not update all the places that you're supposed to, and therefore you have inconsistencies within the data. Redundancy was a huge problem with file processing systems. The other problem was the lack of integrity of data. You may, for example, because the sales data was not tied to the employee data, you might have the possibility of having a sale made by an employee number that doesn't exist in the employee table. All right, that would poses all sorts of other different kinds of difficulties. So with file systems, every piece of data was stored, so every kind of data was kind of stored in its own little cubby hole, and it was very difficult to share and combine things together. With relational databases, everything is stored in a single database. The advantage then is the data is tightly integrated. Instead of having the sales rep in two places, the sales rep's only in one place, and every place that needs a sales rep simply points to that information in the database. So everything is integrated. You can't have a sales then that has an invalid employee number then, because the things are very tightly integrated. And as we go on in this course, we'll see more of how you actually accomplish that. The thing to keep in mind now is that in the past, files were really little standalone blobs of data. whereas databases are taking all those little individual pieces of data and putting it into one structure that's very tightly integrated. You eliminate redundancy by doing that, and it's easier then to combine data from different places. And if you remember from our example before, really being able to combine individual pieces of data with other pieces of data really is one of the key things in transforming data, the raw facts, into information, something that is actionable, something that some conclusions can be made about.